Hello class. We are going to do today's lesson on a video. The great thing about a video, you can pause it when you need to. You can rewind it to make sure that you don't miss anything. So we are going to give this a try. You should have some guided notes to help you copy down the notes. And again, take control of your education. Exponential equations are equations that have the variable in the exponent. Exponential equations are found in science, finance, sports, and many other areas of daily living. Again, pause the video if you need to finish filling in your blanks. I am going to move rapidly through the video, through the PowerPoint though. Key concepts that you need to know. The general form of an exponential equation is y is equal to a times b to the x power. A is the initial value, b is the rate of decay or growth, and x is the time. The final output value will always be your y value. Since the equation has an exponent, the value increases or decreases rapidly. The base, which is your b, must always be greater than 0. So b must always be greater than 0. If the base is greater than 1, b it will be greater than 1. Then the exponential equation represents exponential growth. Now, on the other hand, if the base is between 0 and 1, then the exponential equation represents exponential decay. Now, one thing that can get confusing is time. If time is given in units other than 1, for example, if it's 1 month, 1 hour, 1 minute, 1 second, use the equation y is equal to a times b to the x over t power. T is the time it takes for the base to repeat. Another form of the exponential equation is y is equal to a times 1 plus or minus r to the t power. A is your initial value, r is the rate of growth or decay, and t is the time. You'll use y is equal to a times parentheses 1 plus r, close the parentheses, t power for exponential growth. Notice the plus sign. For example, if a population grows by 2%, then r is 0.02. But this is less than 1 and by itself does not indicate growth. That is why we have the 1 plus the 0.02. Substituting 0.02 for b in the formula y is equal to a times b to the x power requires the expression 1 plus r to arrive at the full growth rate of 102% or 1.02. Now also, when you're going through this, you can pause it and make sure you can ask questions if you're not clear. Today we're doing this in class, but in the future we would like to do this at home. Some other key concepts we need to know. Use y is equal to a parentheses 1 minus r close parentheses to the t power for exponential decay. Notice the minus sign. So if we're looking at a population that decreases by 3%, then 90% is the factor being multiplied over and over again. The population from the year to year is always 90% of the population from the year before, a 3% decrease. Think of this as 100% minus the rate, or in decimal form, 1 minus r. Now we need to make sure we look for words such as double, triple, half, quarter. Such words give the number of the base. For example, if an experiment begins with 1 bacterium, then doubles, which means splits itself in 2 every hour, determining how many bacteria will be present after x hours is solved with the following equation. Y is equal to 1 times 2 to the x power. 1 is the starting value because we started with 1 bacterium, and 2 is the rate because it doubles. X is the number of hours and y is the final value. Look for the words initial or starting to substitute in for a. Look for the words ended with and after. These words will be near the final value again, the final value given. Follow the same procedures as with setting up linear equations and inequalities in one variable, like the worksheet that we did yesterday. The following table outlines these procedures. So here are the steps for creating exponential equations from context. So we're going to read the problem statement first, reread the scenario and make a list or a table of the known quantities. Read the statement again, identifying the unknown quantity or variable. Create expressions and inequalities from the known quantities and variables. Solve the problem and then interpret the solution of the exponential equation in terms of the context of the problem. Remember, you can pause so that you can complete your guided notes. Now, common errors and misconceptions that can be made. If we multiply A and B together before raising to the power, that is a mistake. We always need to do our power first. Misidentifying the base. So basically putting in another number in for the base that doesn't belong. And another mistake would be creating a linear equation instead of an exponential equation. So we have to make sure that we pay attention and learn the difference in the wording of these type of problems. All right. Now we're going to look at a couple of examples. Right now I'm going to show you the example, two examples, the problems for them. I want you to try them on your own, and the examples worked out will be in separate videos. So first, looking at example 1. A population of mice quadruples every 6 months. If a mouse nest started out with 2 mice, how many mice would there be after 2 years? Write an equation and then use it to solve the problem. Pause the video before it goes to example 2 and try to work this problem out. Again, you will be able to go to the video over example 1 and see this problem worked out. Okay, now let's look at example 2. In sporting tournaments, teams are eliminated after they lose. The number of teams in the tournament then decrease by half with each round. If there are 16 teams left after 3 rounds, how many teams started out in the tournament? Okay, so now again, pause the video, try to solve this problem, and then you can go to the example 2 video so that you can see this problem worked out. And again, please pause it and ask questions as needed.